Hey everyone, welcome back to the channel. Let me just quickly check if I'm live. I think we are. Good. Okay. Just give me a moment. Okay, so today we will be starting with another topic from our SD sheet, which is dynamic programming. So let me show you the problem for today. This is minimum number of coins. So I'll just explain you the problem statement. So the problem here is you are given an infinite supply of each denomination. So you are given the denominations, okay, as currency, and you are given a target value. So you have to form this sum with the available denominations. You can use any denomination infinite number of times. What you have to do is how many such coins would be needed such that in minimum number of coins we reach our target. And you don't have to return the minimum number of coins, but the coins that are adding up to help us reach this n, the sum that we need to find. Let me just show you this on board. So we are given denominations that are 1, 2, I'll just write 5, 10, 20, 50, 100, wait, okay, 50, 100, then what we have is 200, 500 and 2000. Okay, so just think of it in this way, that you are given some coins of these values, right? Some notes of these denominations, right? 1 rupee coins, and you have infinite supply of such. For example, 1 rupee coins infinite, 2 rupee coins infinite. Now the thing is that you have to pay some amount of n rupees. For example, n is given to you as 43. So what are the minimum denominations, minimum number of denominations which can give you a sum of 43? So that means you have to minimize the number of coins that you are taking, and which denominations you are taking, that is up to you. You have to choose from this list of denominations, but you have to minimize the number of denominations that you are choosing, and what all denominations gave you this sum, that is what you have to return in the list. Okay, so for example, if I see I can get 43 by taking 1 43 times. Also one of the cases can be this, I take 1 43 times, right? This can give me a sum of 43. But is it the minimum? Taking this 1 rupee denomination 43 times would give me the sum of 43, but I have to minimize the count of denominations that I am taking. So I can check this thing by taking 2 rupee coins. How many times? So 2 into 20 times if I take, I'll get a sum of 40, right? But still 3 is left, so let's take 3 coins of 1. So for 20 coins of 2 plus 3 coins of 1 plus 1 into 3. So basically 20 plus 3, 20, here you are taking 23 number of coins, which is altogether 20 number of 2s and 3 numbers of 1s. So from 40 you reached till 23. There are possibilities to even minimize it more. So this was some small examples that I showed you, that you can try it out with 1, 2, but if you're going to go ahead and try it out with each denomination like this, it will take you a lot of time, right? For each denomination you are trying to make a sum of 43. So this is not an optimal way of doing it. So what can we possibly do? So before I move ahead, let me tell you, there are a lot of variations that are created out of this question, coin change. Okay, so in this question we are directly asked that we have to return the list of such coins we are taking. Okay, and not the number of coins. They have not asked us number of coins that we need to take. Rather they have asked us what are those coins, what are those denominations that you are taking to make a sum of 43. So in this case the minimum that you will be taking will be, if I take denomination 20 2 times, 20 rupee note once, 20 rupee note again, and then we are left with how many? 3, right? So we can take 2 ones and 1 ones. Okay, so basically we are taking 4 coins altogether. Okay, So what you have to return is the list which contains these denominations. Okay, so what can we possibly do? Basically this question can be better way easily solved using greedy approach. That's what we are going to do. Although if had the question been return the minimum number of coins, that's where a better use case of dynamic programming would have been there, and I would have explained you in that way better. But since if you see in this question, we have picked it up from your SD sheet, right? If you go at its view part, okay, in view section the question is slightly different. It asks you, given an array of coins n and a value, target value v, okay, same type of question, given coins, given value, you have to return minimum number of coins required to make this value. Here you are not returning an array list of what coins you need, but rather how many minimum coins you needed. So just one integer is what you have to return. So due to the slight difference, but this problem that they have asked you, why it has been marked easy, because this can be easily solved in using greedy approach. And what that approach is, let me tell you. So effectively, I wouldn't say we are going to do it using DP today. The next question onwards, you will be able to get a better gist of DP. So what can we better do? Just think of it. See, I want to take minimum number of coins. Why not take this list in descending order of these denominations? So think, if I start taking the coins from the end, for example, see, if I take as bigger value of my coin, the higher are the chances that I can reduce the number of coins that I'm using to pay that amount of n, right? So if my amount is 43 that I have to pay, let's start from the maximum denomination that I have. So I'll check. So this array list is limited to some x, y, z, whatever is the length of this array list, and this is fixed for this question. So this length is how many? 1 2 3 4 5 6 7 8 9 10. So basically you will iterate over this list for 10 times, starting from I equal to n minus 1 if your list is in this way, or the other way is your question has not given you this list as an input, so we can directly define this array of coins starting from the higher denomination in the decreasing order. Okay, so you start your iteration from 2000, the highest coin. One by one you keep checking. If this denomination is greater than your n, then you move to the next coin. 500 is also not of our use. 200, 150, 50. When we come at 20, I see 50 is also. When I am at 20, this is the coin that I can take for this sum of 43. So now my sum left will be 43 minus 20, right? So now my new n becomes 23. Please, very simple greedy approach. Simply you are just trying to pick the coin that you have from the list, reduce it from the sum, see how much sum is now left. If you have paid the shopkeeper with 20 rupee note, we will try again with this, because I have infinite supply of these coins. I will not move to the lower coin unless I am done with this bigger value at which I am. I have a sum of 23 to pay now, and I am at coin number 20. Can I still use it? Yes, I can still use it. So I have again first 120 I have taken, another 20 also I have taken. Now when I have paid with another 20, the sum that I am left with is just rupees 3. Now my new n becomes 3. I check the value that at which I am currently is greater than 3. 20 is greater than 3. So definitely I cannot make use of this coin anymore. I will move further to the next coin, which is 10. I'll check 10 is still greater than 3. I cannot make use of this coin. I'll check for 5. Same. For 2, I'll see that 2 can be used to pay the sum of 3. So if I use this coin 2 once, I'll be left with a sum of 1. Can I use 2 again? No, I cannot. So I'll move to the next coin, which is 1. Can I use 1 again? Yes, I can use 1, and now my n becomes 0. So when I'm at the sum of 0, that is when I know I have utilized the minimum number of coins, and the coins that I have utilized, I will be keeping track of them by adding them in an array list. For example, I have created a list in which I am adding list dot add this coins of n, coins of I, at whichever point in time I am at that ith index, that coins of I am inserting into my list. So initially I gave 20. Again I gave this 20, which was this 20. Then I came across 2. I paid it with a rupee 2 coin, and then I paid it with a rupee 1 coin. So this one by one must have been added into my list, which I will finally return. So that is pretty much about this one. Okay. Here we are not making use of our any answer dependent on the previous part that which is actually related to dynamic programming. So I'd suggest that we'll not touch that unless we get that question, because this is simple, straightforward, greedy approach that we are using, in my opinion. Okay, so if you have any doubts, you can ask me. Let me just check. Thank you guys, I can see your comment section. Thanks for the congratulating. Yes, Anshul, that's what I'm telling you. No, we are not solving this using DP, because DP does not have a greater use case in this variation of the question. Whereas when I just showed you in this, if you see the view section of this question, the problem that we have in the view section is a better use case of dynamic programming. This is actually a good question where we can utilize our DP. In this, what we are solving doesn't need it. It can be directly easily done in using this greedy approach, okay, by subtracting n with the denomination that I have. Okay, so that's all about it. You can ask if you have any doubts, else we are done with this. I'll just quickly help you understand the code as well. So see, as I told you, let me just increase the font size. So what we have done here is, we have explicitly defined this coins array starting from the higher value in the descending order. Fine. What we are taking the count of coins, which we don't need actually, because they have not asked us how many coins we have used. We just have to return that list. Even if you don't take this, it will work. This is the array list that I have created to store the denomination that I am using. Now I am iterating over this coins length array. Okay, while my n, why I am using this loop, because I can use any coin infinite number of times. So until and unless that that denomination's value becomes means it becomes greater than my n, until then I will keep using it, right? Because I will not move to the smaller denomination until I pay the sum of whatever current n I have with that coins of I. Okay, so once I have used, so I will add it to my answer, right? Then my new n becomes n equal to n minus reducing that coins I value which I am at currently. Okay, then for the new n, you will again check that denomination that I have, can it be used again to pay that sum of remaining n? If that is the case, again you will add that coin into your answer array list. For example, here 20, again I added 20. Now the sum that I have, I started with 40, I have already paid it with 20, that is 43 I started, 40 has already been paid. Now my new n is equal to 3. Okay, so for n equal to 3, I'll check, I'm still at 20, right? I'm at 20. My n is 3 and it is not greater than 20, so I'll not get into I'll come out of this loop. I'll go to the next denomination, which is 10. I'll see my n is 3 is still less than 10, so you again don't go inside this loop, you move to the next iteration, you check for 5, same case, 3 is still less than 5, there's no point of taking 5 as the denomination. When you come at 2, you check that 2 is less than 3. So you add this 2 into your final answer array list, and then your denomination becomes 3 minus 2, that is 1, and becomes 1 now. You will check again, coins of I is still 2. 2 is less than 1? No. 1 is, it's greater than 1, right? I cannot use 2. So you come out of this loop, go to the next iteration, which is this. For 1, you see that it satisfies, my sum of 1 can be paid using this 1. Now when my n becomes 0, I don't need it, I am already done with the entire iteration on this coins, and you return your answer, right? So that is about it. I hope you all understood. Fine then, if there are no doubts, I'll just wrap it up. Okay, so tomorrow effectively, in the next class, probably on Monday, that is where a proper use case of DP will come. Okay, fine then, if there are no doubts, I am wrapping it up. Okay, I'm just checking your doubt. So for loop for array iteration and while loop is, exactly, you got that right. For loop is for iterating over this coins array, and this while loop is for iterating over that coins I, which I can repeatedly use until it becomes less than the n value that I have. Got it? I mean greater than the n that I have to satisfy. Okay, that's about it. Okay then, bye bye everyone, and see you all in the next lecture. Thank you.